I was in the call alone. Yeah, next time, just give me a heads up, guys, so that I don't prepare speeches and then I have to say them back to myself. But that notwithstanding, very quickly go over what is in store for us. We just have a quick recap of what Gendata is about, and then dive into installing MySQL. So we'll install MySQL. That's what we'll be using for the first 2 weeks as we go through SQL and relational databases, and then that will be that. Then we can proceed on that front. So let me just share my screen. You'll be able to see my screen. Great. So this is Gendata, right, or general data analysis, and our content will revolve around the following. So week one, we will look at in whichever order, relational databases, and SQL. So the idea here will be, first, we need to understand what relational databases are, and from here we will be able to create schemas and ideally create a relational database. So by the end of this, so the journey here will be from scratch, learn all the components or the concepts that are involved in relational databases, all the way to creating a relational database. So that will form 1 week. But we'll start with by itself, or standard query language. And the idea here is, what is this language that is used to interact with databases? And that language will be SQL. So here we'll be able to see how to create tables, how to extract information, update information. So in essence, perform what we call CRUD operations. And as we progress, we'll look at more advanced concepts, right? How to write more complex functions, performing aggregations, performing what we call windowing, and we'll get to look at all that. And then we get into Excel. So here we start from fundamentals all the way to a couple of complex formulas. So we acquaint ourselves very well with Excel. And then finally, we look at Tableau. So here, this is a tool of choice for dashboarding or BI or business intelligence info. So we'll take a look at Tableau. So that will be the format. And then of course, we'll have our capstone, which ideally will have a touch point on at least 3 of these. So one part could be creating our database from scratch, which will demonstrate our SQL and the concepts in relational databases. And then from there, you can use that data and create dashboards, reports on Tableau once we get to that point. So far, so good. Any questions on that flow, on what is in store for us? That is clear. Okay. So before we kick things off, do we have MySQL installed? Do we have MySQL? MySQL.
On my side, I've downloaded.
You've downloaded, nice. So you've installed the Workbench as well?
Yeah.
Nice. Very good to hear. Samora, on your end? MySQL, MySQL?
No. I'm not sure. Let me confirm.
Just confirm kindly. Just confirm. So as you do that, I'm opening MySQL Workbench. I'll just connect to that.
Yes, I have on PyCharm though.
Fantastic. On Python.
Yeah.
Well, it shouldn't be a problem as long as you have an environment that you can run MySQL in. That should be good enough.
Okay.
All right, fantastic. Great. So with that in mind, we should be good. That saves us a lot of time, which is quite good to hear. Now, when you talk about MySQL, right, and allow me to just go back here so that we can introduce these concepts. We'll start with databases first. So I'll introduce relational databases, and then we'll come and look at SQL, and then I'll take you guys through MySQL. So ideally, when we talk about a database, what comes to mind? And given the fact that some of us already had, actually all of us had some version of, some environment to run SQL in, then databases should not be very new concept. So maybe we just go around the room. What comes to mind when you hear of a database? Samara, you can kick us off, and then we'll hear Ricardo's take on what comes to mind when she hears of databases.
It stores relational or unrelational data.
Okay. So keywords there, relational or non-relational data. So we'll just refer that. And what do you mean by this?
Non-relational is like MongoDB. Relational is they're in tables, and then you can link them through, I think, keys.
Very well put. Rows and columns, and then here we have different formats other than rows and columns, and you gave an example of one of those DBs called MongoDB. Good enough. Ricardo, what comes to mind when you hear databases?
Okay, from my end, I just speak about the type of keys that you use when you're using database, the foreign keys and the foreign key and the primary key. So that, let's say when you're talking about the primary keys, yeah.
Go ahead. Don't let me interrupt you. Primary keys, foreign keys. Feel free to define them for us.
I defined the two of them. For foreign key, primary key, it's uniquely identifies each record in a table for the primary key. And for the foreign key, it links one table to another.
Very correct. Also uniquely identifying that. So the difference here becomes where they lie and what we reference them against. I can tell databases are not very new to us, which is a very good thing, which means that quicker we'll get to more and more advanced concepts. We start talking about, we go do CTEs and the likes, and that's really good to hear. So I'm hoping today we maybe go through all the quote unquote basic queries, and that becomes a very good starting point. So that's the whole idea. So database is just a place where the idea there is, how do we store and manage data? And when we are storing and managing data, of course, we are becoming very aware of the fact that this data might be stored in different formats. And that is informing us that, well, that means we need to store it differently. And that's where we have different types of databases, as Samara was pointing it out. And the idea here is each of these databases will cater for a particular type of data. So at a very high level, we have, and you'll find different variations of these, but very high level, we usually have relational databases, also called SQL or SQL databases, and we have NoSQL databases. And in relational databases, here we are looking at databases that will store data in rows and columns. So relational databases, as we said, relational data in rows and columns. And then the relational aspect of them becomes that we're able to look at these different tables, which ideally will be representing entities, and we start finding relationships between them. And those relationships will be guided by those keys that we were talking about down there. So those are relational databases, and we have very many examples. So ideally, these management, we see them being referred to as RDBMS, so relational database management systems. We have quite a number, right? Different flavors of SQL. You have MySQL, which is one of those that we will be looking at. We'll be working with MySQL, but you have PostgreSQL, also quite common. And the syntax changes slightly across, but give or take, they'll be the same. So you have Oracle, MySQL, SQL Server, Microsoft SQL Server. So all those are various examples of relational databases. And the idea here is, one, we have rows and columns, and two, we have some relations between these different entities or these different collections. And then for NoSQL databases or non-relational, also known as NoSQL databases, here we are looking at, can we store data that is not in rows and columns? And yes, we can. Yes, we can, because we have data such as images. We have and all these will inform what type of a database you. So if it's textual data, and textual data could have the extensions such as JSON files, etc. So whichever, what we can store in a typical table will have a non-relational database catered for that. So could be key value pairs, right? Documents such as the text that I was mentioning, images, and so on and so forth. And the idea here is we cannot squeeze them within relational databases. And so that is where NoSQL databases come in. You have so many and of different types. And there was a mention of MongoDB as one of those, and MongoDB is a document-based non-relational database, but we have others for images, for data that is in key value pairs, and that could be JSON, but extensions of that could also exist, and many types of that. Our focus, though, will be on relational databases. And in particular, we'll look at MySQL, and we'll explore the syntax of MySQL, go through writing the queries, all that good stuff. On top of that, before we even write queries, the other bit that we will look at will be database design. So relational databases have some guidelines in which they are created, or we will respect what we call a database design here. And the idea here is we will need to very clearly define certain things. So we'll define our entities, which will be our tables, and we'll be respecting some rules there. We'll then go ahead and start defining the relationships well, and we'll see how we do that. And then we'll come across techniques called normalization that will help us reduce redundancy in how we are storing our data. So we look at the various forms of normalization and what we're able to achieve at each of these forms, and to what degree do we say that our database has a very sound design, is scalable, and has a little to no redundancy in itself. And those will be part of the concepts we'll look at when we get to week 2 of database design and looking at those ideas. That's when we'll go but even as we write the queries, of course, we'll be referencing columns. So we'll be hinting towards these things here and there. So that will definitely come up. All right. Fantastic. So I'll come back here. I want us to run this query. So there's this, I can share this as is, but also when you go to MySQL sample database, this one here, to their website, give you some query to write that creates a database for us, and I want us to continuously reference that. Here it is. So you can download this right here. It will just give you this line of code, and we'll create this database here called classic models. So I can share this. Let me see whether it's possible to share it on chat, if it will be able to fit here. And I want us to run it in MySQL Workbench, if that is what we are. Okay, it's too big. So I just have it in our Discord here. So classic models query. Okay, so it's attached it as a text, not a problem. Just download it and then open it within. Let's see, that's okay. Within your MySQL workbench. Still being sent. Alternatively, as I was saying, just come here to MySQL sample database. This one here, click on download. It's going to download that same file that I'm sending to you. This one here. So let me just confirm. Just double click on it. This one here. This is .sql. So it's a SQL text file. So what I'll do is let me even just share this link on chat. Just click on this, download that file, and then open it in MySQL Workbench. And I'll take us through this interface before we get to that. Just give me a thumbs up once you download it, so that I can take us through MySQL Workbench, the interface, what is what, and before we run that query. Just give me a thumbs up once you download that data set.
Just a confirmation, like we're downloading another one.
Not another one. This is it's just queries to create a database within MySQL Workbench.
Okay.
So we're not downloading another MySQL. Just these it will be queries. So it will take you to this page. Come and click on this button, download MySQL sample database. Should be a file with a .sql. Of course, it's a SQL file. So a SQL file that we will run now in Workbench. It will help us create that sample database that we will keep referencing. Do we have it? Do we have it downloaded? Just locally in our PCs. Okay. All right. You can see same case for Samora. That's good. So we'll go to Samora in your case to whichever ID you're using, and then we'll get to show you guys how to just load it or open it as a file. But it's the same thing that we've been doing with Python files, so it shouldn't be a big deal. Before that, I'll take you guys through MySQL Workbench, which is this database management system that we'll be using in this case. So MySQL is open source, by the way, right? And we'll be using these Workbench as a user interface, so the GUI for this. So it's very easy. It allows us to perform some administrative functions, as well as just have a visual environment where we can do our query execution, look at our schemas right here in the design of our schemas and all that good stuff. So I have so many files open, not a problem. But the idea here, so to take you through, you have this left section right here, or what we can call the navigator pane, right? It's called the navigator. So this pane here, and it will contain all your schemas. In this case, the schemas are all the databases that you have. So in this case, I already have classic models here, which is what I want us to run. And when I click on it, I can see the tables in classic models DB. The icon there should be able to tell you that. The views, the stored procedures, and the functions. So when I click on tables, you can see these are the tables that I have. I have a customers table, employees table, offices table, order details table, and orders, payments, product lines, and products. So all good stuff. And then when I click on views, I can see the views that I have created for these very tables, stored procedures, and the like. So this is the navigator right here. So here, any database that we create, we'll be able to see it here. We'll be able to see the schema. And when I talk about the schema, think of the contents of the table all the way to the data types and all that stuff. So we'll be able to see that here. At the very top here, so here, this will be the section where we'll be writing our queries. So this is a quote unquote the query pane. You'll be seeing it right here. And by the way, we also have an output section down here that will tell us whether an output a query has run successful. So we'll be able to keep track of that. Here we have our file. So file here, you can from file you can open a SQL script, which is exactly what I want us to do. When you click on that, it just opens your file manager. Find that data that you've downloaded. So in this case, from wherever it is, if it was a download file, feel free to a zipped file, feel free to extract it. And when you click on this, you will open it as a file right here, and you can start writing it. Great. You have a view. Another one very important will be query here. So the query will allow us to execute whatever it is we select in the query pane, or the current statement. So it depends. You can run from here, but I'll also show you guys how to run from here using these lightning symbols, and also by positioning our cursor the right way. We have the server here. These allows us to check the status of the server. In this case, when I click on that, you can see it is running. Sometimes you'll find it's not running. So these are some of those administrative functionalities that I was talking about. So had we been running some queries, we'd be able to see, and there you go. In a few, start seeing just some metrics with regards to database administration. We won't dwell too much on this, but very possible on MySQL Workbench to keep an eye out for this. But the most important thing is to ensure that our server is running at the point where we want to write some queries. So here, the other thing is, so performance reports, you can get them here, so on and so forth. But as I said, most important, ensuring that server is running when we are doing our queries. Okay. Great. And that will be that. Here, these are just shortcuts to most of these options here. So opening, creating a new SQL tab like that. So a new tab to write our queries. And here, this is a folder. You can create a new a new schema here, or a new database. So all these will be shortcuts for whatever is happening up here. So that's the whole idea of MySQL and MySQL Workbench. So the Workbench is just the UI for what we'll be doing. Okay, great. So first things first, I want us to go through, and allow me to just look at some slides here. Just a minute. Let me open those slides. Seems I'm having the fastest internet around here. It's taking its time. Still allow it a minute. Okay. Oh, good. So this is exactly what we were talking about when we were referencing databases and all that type. I want us to come to this. Great. Right here. Just confirm that you can see my slide. Feel free to unmute because I'm sharing my entire screen. You should be able to see this slide on SQL. So you can even, in fact, we'll just start from ER diagram. Just let me know. Just feel free to unmute. Just give me a verbal confirmation once you can see I'm on some slides here.
You can see.
All right. All right, I can see. Just had a feeling Ricardo was giving a thumbs up. Fantastic. So when I mentioned, and this will be important too, even though we are not going deeply into these concepts now, rather we'll go deeply into them in the second week. As I said, we'll be touching a bit, going to writing the queries, but a few very important things to have at the back of our minds is part of the schema or the journey towards creating a relational model or a relational database rather usually starts as follows. So there's always first and foremost is the requirements gathering phase. The idea here being you just getting whatever you want to represent as a document, right? It could be a team has shared some documents based on their operation. Maybe it's a hospital that does A, B, C, D, and then you're taking these things and then you're using this information on how this business runs or how a particular operation runs to inform you on how to create that database. Following that, one of the crucial steps amongst there will be creating what we call an ER diagram or an entity relational diagram. So I have skipped a step there, but not a problem. So an ERD, in the case of SQL, will refer to a graphical representation of your data, and it will contain entities, attributes, and relationships. So entity, relationship, entities, and the relationships. And when we talk about an entity on matters relational databases, we are talking about a real world object. And the idea is this real world object is what you will refer to real world object as an entity or a table. This is what will become a table, right? In the cases of a business, such as in this sample data set that we were looking at here on MySQL Workbench, these classic models, customers are an entity, employees are an entity, offices are an entity, and each entity will have attributes or characteristics. So an entity or this entity will become a table, and then we'll have attributes. And you can think of this as the features. And what we'll have here is these will be the characteristics or what we will have as columns that will be describing our entities. And following that is relationships. So how do these entities interact? Very simple description here. Let's say we are creating a database, a relational database for a shop. A shop will definitely have customers who are buying from that shop. We will also have products which are being bought, for instance. And then we can have something such as orders. We can be recording the purchases or orders as follows. And something like the purchases will involve data from the two different tables. What do I mean? We'll have a customer who's purchasing a product, meaning there will need to be a relationship between these purchases and our other entities, customers, and our other entity products. So either we have a column here to uniquely identify a customer and the product that they bought. And we'll get to see the different types of keys that we have here, or the different types of ways we get to represent this information. But that is what we mean by relationships. So we have an entity, we have the attributes. So here it could be the first name, the second name or last name. We can store their gender, maybe even their age, right? And all these important components when we're doing some future analysis, maybe where they live, so where is their residence, get an email address also. See, this is what we mean by the attributes. And for the products here, you could be getting maybe a product ID to uniquely identify a product. You have the name of that product. Maybe we even have a description, a short description, if needed, of that product. And if we're using this to keep our stock take, then we have another column for stock, or how much of that product do we have. So this information, and remember you're starting with a document, as I said, someone just you receive from interaction. Of course, you translate it to a document at some point. You're just mapping out every single thing that a particular business does or a particular operation runs. If it's a hospital, you're mapping out that we have patients here who come and visit our hospitals. We offer maybe both inpatient and outpatient care, meaning we have some wards here that we can host some patients who can spend the night. We have a pharmacy, we have a lab, we have, and all that. And from understanding all that, you then come and identify the entities. What are the main players in your operation? Those will be your entities. What attributes do we want to record of these entities? So what are these columns? What are we storing in the columns? And then post that, what relationships do we draw so that we have entities having relationships with other entities? And this helps us now map out the whole operation, which is, of course, relational. And the idea is usually storing data in as simple a format as possible in terms of one entity at a time, and then introducing the complexity using the relationships. And we'll get to see how we do that. And so when we come back here, that is what we mean by an ER diagram. So an ER diagram will represent all that information in a visual, so graphically, and that will look like this. So allow me to draw your attention to this slide. Let me just zoom in a bit. And these, whatever is happening here in terms of the shapes and what is joining these shapes is very important, right? So these all has a meaning to it. We'll get to that. But the idea here is, in this case, we have the entities in these blue squares. So you have a customer, you have a mobile network, you have a bill, and you have a login. And then between them, you have the relationship. So a customer pays a bill, a customer purchases a mobile network, and between these, you have a definition of what type of relationship exists there. You have a bill or a mobile network which will create the bill, and you have a mobile network which will maintain a personal a login, maybe a customer's login or so. And so what we have here is we have an entity and all the attributes or the characteristics that we are keeping track of for that entity. So customer, we are recording the customer name, their customer ID, the phone number, the city, and the amount paid. And then in the mobile network entity, we are keeping track of three things: the name of the plan that someone is on that mobile network, the price of that plan, and the ID. plan ID. And so a customer will be purchasing a plan from this mobile network. And that's why we have this definition of this relationship here. A customer, again, will pay a bill. And for the bill, we are recording the bill ID, the balance, and the customer ID. And here you can already see that this customer ID is because we want to associate every single bill with an individual customer. And then we have the login, which has an admin ID and a password, and maybe that just gives authorization on maybe unlocking some product post having a subscription of sorts. So this is what we call an ERD. So it will have the entities, the relationships, entities, attributes, the ones with the ovals, and the relationships between those entities all mapped out in a representation like so. Any questions up to this point? Any questions? Are the concepts clear? Feel free to give me a thumbs up if we are together. All right. So all these will be vital. Even when we start writing our queries, as we practice those queries, we'll get to understand why we are querying the way we are querying. Fantastic. So back here. Now, this is a definition of terms, which we will reference again quite a lot. First being the table, which we've come to understand is that representation of that entity, that main player. And of course, you'll have columns being the attributes or the characteristics of that entity. And the rows are just the number of instances of that particular entity. So if it's a customer, every row is a single customer. Columns, also known as fields, will be the representation of the attributes of an entity. We'll also have data types, which are not strange to us. We've worked with data types from the very beginning in Python. The idea here is we are specifying, again, the data type of each of those columns that we are creating. We have the relationship, which is defining the relation between two entities. So how are they related? How are these? It's a relational database courtesy of these relationships. So that is what defines the interaction between two entities. We have indices, and these ones, the idea here when you hear of an index is just to boost query performance. So the idea there is it's just the introduction of columns that will allow access, modification of data quicker than adding normal queries without index columns. We'll have constraints. Constraints very, very important. Rules and conditions apply to the data. They will inform or they will help us guard ourselves against a user case where we have a schema that will restrict some type of data from being saved. And in this data that we do not want to be saved in a type of way. So we'll be able to guard our entities by using constraints that will lock or ensure certain behavior in certain columns that we have. And then you'll have primary keys. I just like them to call them keys because we have so many types. We have primary, composite, foreign. We'll get to see what those are. But think of a key as a unique identifier of every row in an entity. And here we're talking in the table. In another table where it references another table, does not matter. What it will be doing is uniquely identifying every single record in a particular table. Right? Any questions on those definition of terms? Any questions there? All right, moving on. Now, from an ERD comes a schema. So a schema will look like so. So what the addition here is that now we are moving away from the shapes and we are representing all the entities with a list of all the features, the data types, and drawing lines where those relationships exist. What do I mean? Here, we did not care about how these pairs will be represented. Neither did we mention the data types of these attributes at the E and D level. But when we get to the schema itself, we will need to specify the data types of each of the columns. And where we had a relationship, we'll already have figured out how to represent it. And there are different ways of representing relationships depending on the types of relationships. So in some cases, it could be you add one column to the other column. What do I mean? Here you have customers buying products. So in the orders, since the orders are being made by customers, we will include a foreign key. So we will include a column of the customers in an orders table. So that's one way of representing that. And we'll get deeper into that, let's not worry, but just giving you an idea. In some instances where the relationship is different, we can have what we call an associative table. An associative table will just will be made up of multiple primary keys from other tables that the goal there is to help represent a specific type of relationship in the best way possible. So those relationships, we look at the types and we look at how we land on either of those routes, either an associative table or the inclusion of foreign keys in specific tables. So either way, we have moved just past mentioning that we have a relationship here, but by encoding it in the schema. So in this case here, we have a couple of entities. We have order items, orders, users, merchants, products, and countries. Within that, we have the columns. So in the order items table, how many columns do we have? We have 3 columns: order ID, a product ID, and the quantity. And you can see it is already referencing something. It's referencing some products and referencing an order. So you have the orders here, which has the ID, order ID, the user ID could be the user who's made the order, the status, and the created at. So what we have is an entity. We have the attributes and the data types, and then you have lines here that are representing the relationships between any 2 entities, and even specifically on what columns is the relationship existing at. So from this, let me mention 2 relationships that are already there, and then you guys will just mention 1 or 2 based on that pattern. So in this case, I'll start with this. We have an orders table here. So we seem to have orders, and we are keeping track of unique orders using an ID column here. And then we have a user ID. Ideally, that is the person making the order, the status of that order, and what time it was created at. And actually, watch I should buy, but still fine. That data type is not the best. And then in order items, we are keeping track of the order ID, the product ID, and the quantity. Now, what is happening here? You can see there's a line between order ID and this ID. So in order items, the order items is just interested in get that order, what products were they, and how much of those products are required. So it's not being interested in storing who has made that order. It's just a collection of all the orders, what was ordered in terms of the products, and how much of it was ordered. And you can see there's a relationship, obviously, between this order ID in the order items table and this ID in the orders ID. Why? Because this order ID is referencing the orders in this table. So ID here is a primary key, order ID is a foreign key in the orders table. That is one relationship. And another one is, of course, this product ID here is referencing this products table ID column, where this ID is a unique identification of each product. So instead of storing all these details of the products in these, each of them as a column here in order items, we just store one unique identifier that will be able to help us fetch the details of that product from this. So we have a relationship between the connection here is this product ID is a foreign key in this order items table, but it is because it is a primary key in these products table here. It's a foreign key in the order items. It's a primary key in the products table as the ID column. So there's a relationship between order ID and ID, product ID, and products table ID column. Any other relationships we are seeing and what it could be representing? Feel free to unmute. We can start this time round. We started with Samora last time. We can start with Ricardo. What relationship are you seeing in this schema? What might it be representing?
Okay, just a second. I'm just looking at it.
Yes, Ricardo, please go ahead. Yeah, take your time. Take your time. I have looked at this schema for a while, so it's the first time you're seeing it. Should be able to take a while.
Okay, I'm not sure. Okay, on the presentation of the countries and the users, maybe when you're talking about the full name and the name,
Okay.
I'm sure.
So okay.
Like, the full name and the name in the users and in the countries, and yeah. So I was talking about the full name and then maybe the name. So I'm not sure.
Full name and name. Good try. Yeah, but that is not quite. Just look at the line. The line that is joining the users and the countries table. What columns is it referencing, or what attributes? Look at the line between the users and the countries. Country code and code. Have you seen that? Yeah. So what could be happening here? What do you think could be happening?
Okay, let's say for the users, like when you're checking on for the code, like in the countries, like ataweza kuona ya the code, not the other, like the names and the continent name. So I'm not sure. That will be given to them.
You're actually on it. You're not that far-fetched. So what is happening here is we have a users table here, right?
Yeah.
Yes. And we're storing the ID of the user. So that's give or take the primary key. We have the full name. We have the email, the gender, the date of birth, the country code. So what this code is referencing here is it is referencing the code in these countries table. So you have a table here of countries that has the code of the country, the name, and the name of the continent. And so what we have here is in the users table, we have a country code that tells us the country, or that can give us information about the name and the continent name of the country that a user belongs in. That's why we have that relationship. Makes sense?
Yeah.
So the code here is a unique identifier of a country, and it's a foreign key now in the users table, helping us know each user what country do they belong to. So we're able to create that relationship. I'm hoping it's clear.
It's clear.
Any questions? Now, if you have any reservations, let me know.
I think so. It just take a bit of time when giving a relationship of the above, but can you, let's say, maybe checking on the products and the merchants and that?
Okay.
Yes. Let's say,
so let's start
I'm
with
checking
product.
on the ID.
One step at a time, right?
Yeah.
No, go ahead. I think there's a bit of a lag. Let's say you're checking on that. All right. So let's take a look at this products table. We have a product ID. We have an ID column. So that is the unique identifier of every product. So in this table of ours called products, we are storing the ID, the merchant ID, which we don't know what it is yet, but we can see there's a relationship there. we have the name of that product, the price of that product, the status of that product, and when it was created at, correct?
Yes.
So far, so good up to that point? Yeah. But this merchant ID here seems to be the primary key in a table called merchants, which has the ID, the name of the merchant, the admin ID, the country code, and the created at. So what is happening here is we are creating a connection in the products table to tell us each product, which merchant sold that product. That is why we are storing the primary key of the merchants as a foreign key in the products table. So based on this based on this relationship rather, we can fetch other details of the merchant if we want to. But what we are having here is within the products table, a unique column to tell us this product is from this specific merchant. Is it clear?
Yes.
All right. Samora, you want to take up one? What other relationship do you think exists, and what will you deduce is going on there?
From the users, I can see you can either be a customer or a merchant. In terms of when you look at the users table, the ID goes to the orders, and from the orders you go to the order items. So that means it's a customer.
On what column? What column are you seeing?
From the line touching on the ID, it goes. There are two lines: one going to the orders, another one going to the merchants. The one going to the orders is called. It becomes a foreign.
From which table we are starting on? The users table.
Users table.
I think there's a bit of a lag. Can you hear me well, Samora?
Yes, I can hear you well. Can you hear me?
Okay, I said that statement a while back. That's how I'm confident there is a serious lag.
I can hear you clearly.
Let me know if. Fantastic, great. So you were referencing the users table, right?
Yes.
Okay, so how many relationships exist between the users and direct ones? Direct relationships, that is.
There are two relationships between the users table and the orders table, and the users table and the merchants table.
Fantastic.
So it means the user can either be a merchant or a customer.
Very good, very, very good pick. Yes, it means exactly that. Yep. And in one table, and you can see we are storing them as in the admin ID of the merchant. So very interesting. And we don't need to know the need. From this schema, we can't be able to figure out what exactly is going on. But it's a very fair shout because of that, because we can say that the user ID exists as a foreign key in both the orders and the merchants table. So that's a good pick for sure. And then finally, there's one relationship we haven't caught yet. There's one relationship. Remember, we've done order items and orders, order items and products, products and merchants, users and orders, users and merchants. Which one is left? There's only one left.
Products.
And not quite, we've done products. There's one between merchants and
countries or merchants and.
Look at merchants and countries. That it is. So in the countries table, we are not only using the countries table to keep track of the country of the user, also to keep track of what country the merchants are from. That's why you have a country code pointing to the countries table primary key, which is the code. Is that clear? Are we seeing that? Okay, and I'm assuming there's some thumbs up that I'm not seeing. Fantastic. Great. So that is a foundation, and it's a very important foundation to have because the whole idea of relational databases is based off of that, of entities and relationships. And if we understand these relationships, we then understand why we'll be doing joins. We then understand how any of our complex functions, because very rare will we be writing a query that is just referencing one table. Most queries will reference, because we are trying to summarize against multiple or try to paint a picture across multiple entities. So you're getting something from the products, joining it with something else somewhere else, and it's becoming something awesome. So that's the whole idea. Great. So on to now the SQL queries and how they will look like. So the syntax of SQL is very English based, as we will figure out. And the main operations that we'll be doing on SQL, they are usually called the manipulation. They usually call operations are called CRUD operations, short for create, read, update, or delete. And this is exactly what we'll be doing. And these are the most basic or fundamental ones. We'll either be creating a database or creating a table and inserting data into that table. And the keywords there will be create table, create database, and insert into. Those will be the keywords while creating tables or databases. To read, we'll be selecting from. So select from a specific table, and then we can either add some conditions, which we will look at, so on and so forth. But the keywords there are select from. We then have update, and update will be modifying records that already exist in a table, and we will be saying update blah 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 set blah 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 to now the new value. So the keywords there, update, set. And then delete, here you're removing an entire record, an entire table, or in some instances even dropping the entire database. So the syntax there is delete from, or we'll see drop followed by the name of the table. So in that case, we'll get to see, but it's very English-like as you're seeing. And these are the keywords that we'll just see us reference this more and more as we do more and more operations, but that same syntax will hold across board. And then let's look at the data types that we have in SQL. Given, remember, we've seen our schema must have the data type for each column for each entity. Right? Every entity, each of the attribute or the feature or the column, we have to reference. We add the data type. So we have int, so this we already know, this we're talking about whole numbers, so representing integers. We have decimals, so representing decimal numbers. We have varchar, or variable character. These will be anything that we are storing as a text, and we will put in brackets the number of characters we expect maximum to be stored in that particular column. We'll have date, representing date. We'll have timestamp. We'll have Boolean. So the new introduction there will be varchar. We haven't seen that so far. Everything else quite common, but varchar will just be how we specify that we expect text to be stored in this column, and how big in terms of the number of characters we expect. We will specify that as a parameter after the varchar. Great. So these will be the commands that we will be. So just a recap of those CRUD operations. We'll be selecting. We'll be creating tables, databases, selecting, or even in fact before selecting, we insert into, we select, and then finally we drop, delete if we need to do that. But that sums up the CRUD operations end to end. So with that foundation, we are now ready to go into our MySQL workbench and at least create our first table, right? We should be able to do that. So we started creating a small database. So create a database from scratch, and then we'll create a table, and we will see how that looks like. Any questions? Any queries? Okay, sounds good. So back to MySQL workbench right here. So Let's create a new file. So come here to this plus, and this is after opening and connecting. Once you're on this page, just click on this plus. Once you're on your this query editor panel where we are writing our queries, first thing we'll do is create a database. And the command for creating a database, as you said, so we need a database which will be our schema, and then we will use that schema, and then we'll go ahead and create columns as we go, create tables, add columns as we go on through. So let's start with create the name of our database. So create database and give it a name. So in this case, we will call it create database. Let's call it sample DB. We'll end with semicolon, not a must, but it's a good convention. It's a good convention across multiple SQL flavors. So it's not that when we write without that, it won't run, but it's just good because this behavior exists across multiple SQL flavors. So once I have that, I'll just highlight that statement. And in this case, it's because I just want to run that line or that block of SQL. I'll come here, and then on that lightning symbol, I'll execute the selected portion of the script. So run that, and we have create database sample DB. And you can see down here, there's a tick, one row affected. And I'm hoping we're together. I'm hoping we're going hand in hand. If you've not yet opened your, just let me know once you've done this and it's okay. So create database sample DB. So I'll just come back to, I'll alternate between these two so that I can see your reactions. So we have created a database sample DB. Let me know once we do that. Some more on your end? All good? Are you having any challenges? Fantastic. So once you create a database, to start working on it, we use followed by the name of the database. So you use sample B and then the semicolon. And once I run that, so highlight it again, click on this, run it, then you can see that now I will be working within sample DB. And we can refresh here in the schema. So if I run that and I refresh, you can see that sample DB is now highlighted the schema that I'm now working within, sample DB. So use sample DB allows us, or allows whatever database we are referencing there to be the one that we effect any changes on. So from reading to writing, all any operations will now be on this sample DB that we've just created and said we want to use. Fair enough? Any questions? Okay, so let's proceed. Let's create our first table. So the syntax to create a table is create table. So start with those two keywords, create table followed by the name of our table. In this case, let's call it customers. That's step one. We are creating our table called customers. I will then insert my parentheses there and hit on enter. And then I'll start including my columns one at a time. So in this case, let's say we will have the name of that customer. So I'll come say name, or customer name, customer underscore name. It's good not to have spaces, followed by the data type. Now the name is varchar or variable character, and I'm anticipating that I will not go beyond 100 characters per name. So I'm putting 100 there. So that's the first column. So customer name. Let's say we will email as well. still as a variable character. Maximum length, I'm repeating maybe 100 again. And then we can have the age as an integer like so. And then once I'm done, I have my semicolon at the end. So this integer should not be in brackets. There we go. So we have our table called customers with the customer name, and the data type is variable character or varchar. When I say 100 characters, we cannot go beyond any name that I'm putting a number here that I'm anticipating there is no customer name that will go beyond 100 characters. And then the email, varchar as well, 100 characters, and then the age is there as well. So I'll just come highlight that whole block of SQL, run it, and you can see at the bottom here that has run successfully. And I can come here to this navigator section, refresh, come on the sample DB. When I now open the tables, you can see I have my customers table, and I can see my columns here: customer name, email, and age. I'll just leave my screen there for a bit so that you can reference that. Okay. Let me know once we have this, and you can run it and ensure that we can see it here in the sample DB. Just give me a thumbs up once you can do that. All good on your end as well? Samora, all good on your end? Fantastic. So very quickly, it's starting very simple. So we'll go through constraints tomorrow. So what I want us to do is let's insert some data into this. So the syntax of inserting data into a table is insert into, those are the keywords, insert into followed by the name of the table that you want to insert data in. So insert into customers. And then in the parentheses here, you list the code that you want to insert data into. Very simple, some column names or change the order, and that affects the output. So in this case, for simplicity purposes, we'll just name our customer name, email, and age. So insert into customers, and leave a space here just for readability. Values for the customer name, the email, and the age, and then followed by the other keyword values, like so. And then I like to, again, hit so that I can list my entries down here one at a time, and they'll be in parentheses separated by a comma. So our first customer will be, I insert my quotation marks, so either single or double, Alice. Email will be alice@gmail.com. That becomes good. And then the age, you can put 25. That is entry one. Comma to enter, to have the second entry again in parentheses, come here, I'll put John. And then the email becomes john@gmail.com. And then the age is maybe 27. So those two, once I'm done, I insert my semicolon at the end, and that becomes that. So notice, insert into, followed by the name of the table that we're inserting into. And then in parentheses here, we're naming the columns that we're inserting into, and the order, as I keep emphasizing, is very important. And then values is a keyword after that. So insert into and values are the keywords. Customers is the table we're inserting into. And then within parentheses, we are just each entry will be within parentheses, and we are entering those values like so. And then I'll just select that whole section, run it, and can see it's run successfully. And to prove that, I'll just come down here and just have the command select asterisk. That means select all from customers. And this will allow us to display our entries. So I'll just highlight that, run it, and we should be able to see we have Alice, email, and age, John, email, and age. So I'll leave it there for a few minutes so that we can reference it. Just let me know once that is successful on your ends as well. We've inserted 2 rows into our table customers. All good on our end. Samora, Ricardo, all good. Ricardo, any challenges, or are you still typing out the queries?
A second.
All right. You can take seconds, you can take more than one. Feel free to unmute and let me know once you're there, or if you're having any challenges, Ricardo.
I'm good. I'm done.
Just take a quick look. Sorry? All good? All right, great. So very quickly, and to close this output section, you can just click on this X right here. So what I want us to do is I want us to alter our table. And ideally what I want us to do here is add a new column. So we'll add story one. So the syntax here to do, and again, we've created, inserted, and we've read using the select. I want us to alter. So we'll come say the keywords here are alter table. And what table are we altering? We're altering our table called customers. So alter table customers, like so. And then the other keyword is add. The other keywords are add column. That's what we want to do. Followed by the name of the column. So phone or phone number. and the phone number will be an integer. Although since we don't want to do any summations, it's sometimes even better stored as a variable character. Voucher, and in this case, they cannot go beyond 10 in the case of just Kenyan phone numbers. And that becomes that. So we are altering our table customers. What are we doing? We are adding a column, phone number, which will be of data type variable character, and we expect a maximum of 10 entries there. So I'll select that block of query, run it. And to prove that that has worked, I'll just come rerun this select all from customers. So you can rerun queries in any order. In this case, we don't have to rewrite again select all from customers. We'll just select that, then come run it. And we have now, notice we have phone number that is null for both entries right here. So that means we have successfully altered our table customers and we've added that column for phone number. Any questions? Any questions? Okay, give you guys a minute to have that as well. So altering the table, and we can alter in multiple ways. First, we've added a column. We can alter by even dropping an existing column, right? That is also altering a table. So first, the very simple way, altering, can also rename a column. So first we'll can modify it, by the way. By modify, I mean changing the data type, etc, or renaming. So let us rename the phone number to Nambari or something, and then we update our records. So again, I'll just close this section. What I want us to do is rename. So what do we say? We say, again, alter table. So same syntax holds, customers. And then what changes is we're not adding a column, we are renaming column. So rename column. And we are renaming the column that we call phone number. Phone number. 2 is the other keyword to Nambari. Nambari. Yasimu, for instance. Like so. So alter table customers, consistent as always, altering, anytime you're altering a table, that is those are the keywords, but now depending on what we are doing, in this case, we are renaming the column. I'll just highlight that. I'll run it. So it's run successful, and then I'll just come back and select all from customers to ensure that, just to confirm it. And you can see now that column is called Nambari ya Simu up there. Any questions? So here it is. Rename column, old name of the column to the new name of the column. Feel free to just give me a thumbs up once you've done that. All good. Altering by renaming the column. Are we having renaming the column? All good? Some more? You can hear me? Ricardo, seeing no reactions. Okay. Ricardo, on your end, all good? Just let me know as soon as you can hear me, Ricardo. Okay. I'll dive right into the last bit, which is now updating with the new values. What to do is updating. So I've left out a small section here for dropping a column. So still updating, but dropping an entire column. So a big important bit in learning how to alter tables. Let's look at updating records. We need to set these phone numbers based on something. So how we update is, remember the syntax? Update is a keyword. Update the table called customers. So update our customers. And what we're doing is we are setting set followed by what column we want to write. In this case, it's nambari ya simu. So set nambari ya simu equals to, so we follow it up with, given in this case, it's is it a voucher? Yes, it was a voucher. So must have it in quotes. 0712345678. I'll just leave it as that. So we are setting that, and we have to be specific where we are writing this. So where the customer name, customer underscore name is equals to, let's say we are setting this for John. So where the customer name is John, like so. So update customers, set the phone number as this, where the customer name is equals to John. So I'll just highlight that block of code, run that. Okay, so I'm on safe update mode. So I need to disable. This is we'll pick up on that and remove that. It's a feature within couple of relationship database management systems, just to allow you to get of people of editing data that already exists in a table. But this syntax is accurate. It's just that the update mode has been set, the safe update has been set to on, so we need to have that as off. But this is how we update records within a table. We keyword update followed by the name of the table. We set what column we are writing and what value we are writing, and a condition on where we want this data to be written. In this case, we want this data written where the customer name is John, so specifically for John. So that becomes the entire syntax for updating records within my C. So far so good. Any questions up to that point, Samora? I can see he has dropped off. Ricardo's dropped off. All right, that's good. So we take it up a notch from here. Feel free to get straight into the daily exercises for SQL. So in this case, once you're done with the file, you can just save it, right? So once you're there, you can just come, and in this case, I'm on this SQL file 27 div, and I know you're using a different IDE, but should be the same. So here come, you can save script, and then you can save it as day one. Create or CRUD SQL. Just like that. So this allows us to push all these to our Gendata repos with ease. That's fine?
Yeah, that's fine.
Okay. Yeah, that's okay. Let's carry on with this tomorrow. At least today we attended very much on time, and it's good that we had these installed. Saves us a lot of time. So let's meet tomorrow on time as well, so that we can keep pushing.
Kindly paste the that Nini on the chat.
Yes, Samora?
I'm saying
I can see you saying something, Samora. I can't hear you.
Can you hear me? Hello? Hello?
Samora, can you hear me? I can't hear you. I don't know what's going on. Feel free to type in the chat, Samora. I can see that you're unmuted, but I can't hear a thing you're saying. Paste the document on chat. Which document, to be specific? This file, these the one crew.sql. Okay. Okay. Let me see where I've saved it. Local disk, right? Let me just find it. Let me just save it elsewhere. In the documents. Okay. Okay, it's uploading. There you go. Fantastic. So now that's all, Ricardo. We're done. We just added one more query for updating. We'll start with that tomorrow. So let's meet tomorrow on time so that we can keep pushing on the content. All right. Have a good night.
Just a quick clarification.
Go ahead, Ricardo.
Hello. Oh, I was just asking, when are you
I can
sharing
hear
the
you, Ricardo.
recordings of the
I can hear.
Where are you sharing
Where
the
or when?
recordings? Like where?
I will share them where on the chat on our group. I will be sure to drop them in our group, but also on the LMS just next to this last one.
Oh, you have a WhatsApp group?
Not a WhatsApp group, on Discord.
Oh, on the
Discord chat.
Discord. Because for yesterday you never shared.
Yes,
I was just
yes.
checking. For the yesterday's
Yesterday we did
class.
not have a session. No one was there.
Okay,
no
no
one attended.
problem.
I was there by myself. That's what I referenced at the beginning.
Okay, no problem.
Sawa.
Thank you.
All right. Have a good night. See you tomorrow.
See you.